Kayla, welcome to SnapMath. Thank you for sending in your question tonight. Well, I guess you sent it in a few days ago, but I'm just letting you know that our hours for getting your question answered are Sunday through Thursday, 4 to 10 p.m. So that's why we haven't gotten back to you yet. So this question says, we have this graph, and I'm assuming that this is the position graph, the position of a particle. And then it asks, A, when is the particle moving forward? When does it is the position getting farther away from, or have a positive, basically what it's saying is, when does this function have a positive slope? So that would be, the particle is moving forward when x is, well, we'll just do the interval. I'm just going to do the interval, the open interval from, I think this is x equals 5 to x equals 7. So from 5 to 7. So whenever there's a positive slope, that means it's moving away from the or has a is moving forward. All right, and then when does the particle change directions? Well, there's going to be two spots where that happens. That's when it goes from a negative to a positive slope and a positive to a negative. So basically, when the slope changes sign. So there's 2 points when x equals 5 and when x equals, I think that's 7. So those two parts right there, all right? And then the next question is when does the particle move at the greatest speed? What is the speed at that time? Okay, the greatest speed is going to be the slope, if that makes sense. The slope is going to be what interval is the slope the greatest? So there's actually one specific time. It's from 5. It has to be on this interval. It has to be the positive to 6. And then what it asks what the speed is. The speed is going to be what the slope is. So on this one, if we use rise over run, we go up 1, 2, 3, 4 over 1. So it's 1 over 4. So the velocity is going to equal 4. Okay? And then when does the particle slow down? Graph the acceleration of the particle. Okay, well, this one's going to be a little bit difficult because there's not really the graph of I'll show you the graph of the speed of the function. There's not going to be a specific graph of the acceleration. So if we have the position right here, the position function is going to go to the velocity function, and the velocity from 0 to -3 is going to be -3 over 2. So that's right here, actually, from here to here. Okay, and then the velocity is going to be -2 for the next 2, from 3 to 5, right? And then at 5, it changes from 0 to 4, or to -2, all the way up to 4. And then the next one is from 1 to, or at 3, from 6 to 7. And then it goes back down to a negative slope down here, which is, again, -3 over 2. and then the slope here is 0. So this is kind of difficult to take the derivative of all the, because the next one would be the derivative, which would be the acceleration. I'm assuming which one is the biggest jump, and it's let's see. Yeah, it's so which one would be the biggest jump, and then graph the acceleration of the particle. And well, these answers might change because you didn't really specify what was the graph was, if it was the position or the velocity. So here, if this was the velocity function, this would be your acceleration graph, if that makes sense. So if we do the derivative again of this, it's all going to be 0. So the acceleration is just going to look like this. The acceleration graph is 0. And then maybe they're asking for what's the biggest jump, and that would be 6. 6 would be the biggest jump. It goes from -2 all the way up to 4. So I'm guessing for D, we'll just say that, right? So I think that was E. When does the particle slow down and graph the acceleration? All right. Thank you for sending in your question, and we look forward to answering more of your questions in the future. If you have any more questions on this one, please send that back and maybe be more specific on what the graph is. And then we can kind of get into more specifically these questions. All right? Have a good night.